So an inparabola of a triangle, shown here is this magenta curve, this parabola. Here's its axis, here's its focus, F, here's its vertex, and here's the center of its directrix. So this orange line here is the directrix of the parabola. The vertex is the midpoint between the focus and the foot of the directrix. Now, the inparabola of a triangle is simultaneously tangent to the three sides. Given a specific triangle like this one, P1, P2, P3, the family of all possible inparabolas have foci on the circumcircle of the triangle. So here's one point F on this circumcircle, and I can vary F along the circumcircle and show for each position of F the corresponding inparabola to this blue triangle. So this family of magenta parabolas, though it's a varying family, you can see here that its axis connecting the foot at the directrix and the focus passing through the vertex. This axis here is changing position, so it's actually sweeping an envelope. Likewise, the perpendicular directrix is also changing positions, and the parameters of the parabola are also varying as I make the focus of this inparabola sweep the circumcircle. Very well. Now, I want to marry this to Poncelet. And let's go ahead and pick a Poncelet family that has a fixed circumcircle, because we want to use the fact that all the foci for all inparabolas are on the circumcircle. So I'm going to pick a Poncelet family, P1, P2, P3, inscribed in a fixed circumcircle, and circumscribing a concentric inellipse centered on its circumcenter. So this black point here is the fixed circumcenter of this Poncelet family, which I'm going to animate very slowly here, so you guys can see this n equals 3 family of Poncelet triangles being animated with a fixed circumcircle and circumscribing a fixed concentric inellipse centered on x3. The foci of the inellipse are not shown. Now what you're seeing here alongside this family is the corresponding circumparabola, and there's a unique one whose focus, and I said circumparabola, I meant to say inparabola, so let me stop the simulation. This is the instantaneous inparabola. It's a unique inparabola, meaning that it's tangent simultaneously to the three sides. Here's one of the sides to which this inparabola is tangent to. Here's another side, so you would have to extend the side to see the other tangency, and extend P1, P2 to see the other tangency toward the right here of the page, right? So this is the unique inparabola whose focus is the specific point F, okay? If I move F around, I get a different unique inparabola. And if I jog the Poncelet triangle, I get a different inparabola, but with the focus fixed. Okay? Now I want to share with you guys a very cool phenomenon. What is the locus of vertex V as the Poncelet family is traversed? You can see here that V is moving as this family is traversed. Okay, you can see that actually grazes the caustic at some point, and it goes back up, and it's going to go now toward the focus, and it's going to touch the focus. Okay, now the observation I want to share with you guys is that this locus is precisely a circle. So the other thing you're going to notice is that the circle is touching the inellipse exactly in one point. So let's scale this up so we can see this better. So this is a circle that passes through F and is tangent to the inellipse. Okay, so if you actually were to draw the diameter of the circle, you would actually cut the inellipse perpendicular to the tangent, so you just cut straight through the inellipse. If I place F elsewhere, let's place it over here, you can see that this is sweeping a family of circular loci. Okay, so what is going on over here, for example? Let's go ahead and animate my Poncelet. You can see here that even at this position, with the focus placed in this position, the locus of the inparabola family vertices is sweeping this green circle, which has the same geometric property, which is it passes through F and it's tangent to the inellipse. So let's go ahead and place the focus back at this location over here. And I want to also show the locus of the foot of the axis on the directrix. So this point C here is representing the foot of a perpendicular drop from F onto the directrix. Okay, and I can see that this locus is also a circle of twice the radius, whose center is actually this point of tangency. So let's go ahead and move F around a little bit. So you can see that you got these two circles with, so the orange circle, the locus of the foot of the focus on the directrix is a circle twice the size of the locus of the vertex of my inparabola family. So there are more experiments related to inparabolas, circumparabolas, and other kinds of loci that I should be sharing with you guys in the next few hours or days. See you in the next video. Thank you.